A warm welcome to all the viewers. Friends, in this video, I am going to explain to you the concept behind a mixed effect model. So, earlier I have spoken about mixed effect model and mixture modeling. You can go back to the playlist and check on my video on introduction to mixed effect model and mixture model. What is the difference? In this video, particularly, I'll be explaining to you what do we mean by this effect. What do you mean by mixed effect, right? So mixed effect basically consists of two different effects. One is the fixed effect, right? One is the fixed effect and other is the random effect. So what do we mean by this? So when we mix fixed effect with random effect, we call it mixed effect model. Now, how can we have a mixed effect model? Say this is, we are trying to plot a regression equation. So this is x and this is y. So x is the predictor variable and y is the dependent variable. Say x is study hours being put in by a student and y is marks secured by the student, right? So when we collect a sample, we assume that sample truly represents the population, right? But in case we are collecting the sample of student marks from say 30 different schools, we are collecting it from 30 different schools. In that case, each school students will have a different trend line of marks which depends upon school level factors, which is known as second level. So the first level is student level, right? Student. And the second level in this case is schools, right? So this becomes a hierarchical linear model wherein we have two levels of assessment, first level and second level, right? So each school students, their marks will be depicting a different trend line, a different regression equation. Say for an instance, if I talk about the entire population of students studying in that class in different schools, so I can say that if I draw a regression line, it will appear somewhere to be like this, where this point is the intercept and this is the slope, right? This is the slope. So intercept is basically, as I have discussed in previous videos, the value of y when x is 0, right? So for an instance, in this example, while putting in no study hours, the student who puts in no study hours, what are the marks of that student, right? So that is the intercept. And as the study hours go on increasing, does the marks of the students also increase? So as the study hours increase, the marks will increase. That is what we are assessing through a regression equation, right? So slope is, as we increase 1 unit of study hours, it means we increase 1 hour of study, what is the corresponding increase or decrease in the marks, right? So we cannot say that this fixed intercept, which shows us the intercept of the entire population, and this fixed slope, which is the slope of the entire population, is apt, is appropriate to be used in this case where we have sampled the students from 30 different schools, because each school will have a different regression line. Let me explain to you in much more simpler manner. So you see here, if we have 30 different schools, somewhere we can have a intercept at this level and slope, this is the slope. Say this is school 1 and the fixed was this is the population intercept and slope, right? This is the intercept of the population and slope of the population. So this is the population line and this is school 1, and then we might have school 2 which is like this, okay, and maybe we have this one, that is school 3. So this way we will have, each school will have a different intercept and a different slope, right? So this is known as, when we have a different intercept and different slope for a school, this intercept and this slope is known as random effect. So this is random intercept as per the school and random slope, right? So this is the idea behind mixed level effects, mixed level modeling, right? So when we talk about multi-level, we are talking about different schools under which students are nested. So under each school, if we took a batch of 20 students from each school, right? So this batch of 20 students will be having a particular regression line with a different intercept and slope, which varies as compared to other schools, right? So this becomes a second level factor, where is school is the second level and student is the first level. Now when you have understood what is random intercept and random slope and fixed intercept, which is the population intercept, and population slope, which is fixed slope, now how to execute, how to assess this model? So let us see. Random slopes apply to the strength of predictors effect. So what is the effect of X on Y? In this case, study hours and marks of the student, right? What is the effect of study hours on the marks of the student within each school? So within each school. So we have included 30 schools for an instance in this, and each school 20 students we have taken, right? So we have a total sample of 600 students, 20 from each school and 30 schools are there. 600 students is the sample size. Now, this random slope allows the impact of study hours to change depending on school's environment, right? So, in case of random slopes, we are saying that the slope can vary as per the study hours being put in by the students of that school, which of course depend upon the school's environment. That is the pedagogy, the teachers, the kind of training, the kind of exercise, tests, assignments given to the students, right? So if we talk about average baseline score is the average score of all these 600 students, right? All these 600 students average score is the average score. So instead of assuming that every school will have the same baseline average score, a random intercept allows for the baseline to shift up or down for each school. So it allows the baseline, that is average, to shift as per the average of that school, as per the average of that school. So if you are talking about school 1 students, what is the average score of those students? It will shift accordingly. That is what we mean by random intercept model. So in level 2, that is the baseline model, we are comparing schools by the average marks scored by their students. And then we are seeing in the advanced model, once we have determined that the schools are different, then we add level 2 predictors, that is the school level predictors, factors which explain why they are different. Just like I have explained to you, teaching pedagogy, right? Funding of the school, facility of the school. So these are the second level factors which affect the student marks, right? So this is second level factors. So now let us see how to execute this thing in Jamovi software. So I'll tell you the theoreticals over here, and later we can have a practical demonstration on Jamovi software in the next video. Otherwise this video would be quite long. Step 1 is that we have to check the intra-class correlation coefficient. Intra-class correlation, I standing for intra-class, C standing for correlation, and C standing for coefficient. Intra-class correlation coefficient. So it's basically computed as the variance that exists between the groups, that is between the schools in our case, divided by variance which exists within the groups, that is within the schools, also known as residual variance, plus variance between the groups. So it tells us that how closely the items, how closely the respondents in a particular school, in a particular group, are related to each other, which dissolves the assumption of independence in this case. So when the assumption of independence, which is very much required to conduct linear regression, is violated, because here the respondents are not independent of each other in a particular group, so we resort over to conducting a linear mixed effect model rather than simple linear regression. So if ICC value, this ICC coefficient comes out to be greater than 0.05, greater than 0.05, in that case, we can justify using linear mixed effect modeling in place of linear regression, because the assumption of independence of observations is violated in this case, as we have nested data, group data. So the first step here is that we randomize the intercepts, random intercepts. So we add level 1 predictors, that is the study hours being put in by the student, into the model, but keep the slopes fixed. We keep the slopes fixed, right? In this case. So this means we assume that study hours affect marks equally, but school have different baseline marks. So school have different baseline marks, that is what we mean by random intercepts. And then in the second model, what we do is, now we allow the study hours to vary across the 10 schools. So when we allow the study hours to vary, we are actually randomizing the slope. So in this case, random intercepts and random slopes, both of the things are put into place. So in this case, we are allowing the study hours to vary across the 30 schools, and it tests if the benefit of studying changes depending on school's unique environment. So now level 2 factors come into play, and we are assessing whether the factors like teaching pedagogy, exercise, class assignments, or special counseling done in by the school for the students help the student to get in better marks, right? So this is the fundamental behind randomizing the intercepts and randomizing the slopes, which we do of course after first randomizing the intercepts. So now we compare both the models to decide which one to choose, whether we should go in for random intercepts model or we should go in for random intercepts and random slopes model. So how do we compare these models? Let us see now. So comparison of these models, is based upon several parameters. The first being statistical comparison through likelihood ratio test, often called as deviance or ANOVA test. In this, if the p-value is less than 0.05, that's the significance value is less than 0.05 of likelihood ratio test, then random slope model fits the data significantly better, and we keep the random slope, where we have kept random intercepts and random slopes, right? Now, if p-value is greater than 0.05, then extra model complexity is not useful, and we stick with the simpler random intercept model. So in this case, if the p-value is insignificant, we stay with model 1, wherein we have random intercepts and we have fixed the slopes, right? Now, second criteria of comparison is checking on AIC and BIC values. So what is that? Archaics information criterion and Bayesian information criterion. We are looking in for the lower values. So in model 1 or model 2, wherever we find the lower values of AIC and BIC, we pick up that model and we say that that model fits the data well. Okay. Now, third criteria is practically checking the sample size. So if we get a message that model failed to converge or there's a singular fit, it means it is an error. It means it is an error in execution of the model. If variance for slope is 0.000, so if the variance is 0.000, then it means the 30 schools are not enough to support the random school. So then it means that 30 schools which we have considered to collect the data, they are not enough to support the random slope. Okay, so we need to collect more data. Next, what we do is we check assumptions of the selected model. So now once we have decided which model is better as per the information criterion and as per the statistical comparison through likelihood ratio test, and also checked the sample size and error, all these things, and we have decided whether to go in for model 1, that is randomizing the intercepts, or model 2 where we have randomized the slopes also along with the intercepts. So now we check in the assumptions of the selected model. How to check the assumptions and what to check. So as in case of linear regression, here also we have the assumption of linearity. So these assumptions need to be checked, right? Which we can do easily in the Jamovi software. Check in for linearity, check in for normality of residuals, okay, by plotting the residuals against the predicted values. So in this we plot the residuals on the y-axis and predicted values on the x-axis for the model which we have selected, right? And we check the normality of residuals. So one is linearity, second is normality of residuals check. And we can also check normality through the QQ plot. We can check it through the QQ plot, quantile plot as well, which shows us the deviations which exist at the tail of the this straight line. So this line depicts a normal distribution of data, normal distribution, and we are checking on the deviation in the tails, deviation which is present in the tails through QQ plot. If it is not significant, it's okay. By looking at QQ plot, then we say that normality of residuals assumption is fulfilled, right? The third assumption is checking on homoscedasticity. This assumption needs to be checked. This ensures that the variance of your residuals is roughly equal across all the 30 schools and prediction levels. So to ensure that the variance of residuals is roughly the same across all schools and prediction levels, we check the homoscedasticity. And if this assumption is also fulfilled, then we go in for interpreting the fixed effects. So next step is we interpret the fixed effects. The fixed effects, which are the average effect of all the 600 students included in the study. So interpret the fixed effect first. We also call them global results. Okay, we also call them global results, wherein we interpret the intercept and the slope. Next, we interpret the random effects. So after interpreting the fixed effects, next we interpret the random effects. So this is based upon the schools, that is the school's variance. This is done to understand that how much these 30 schools differ from each other. So the intercept variance tells us how much schools differ in their baseline marks. Larger variance means higher impact of schools environment, schools pedagogy, and all those things. And slope variance, so here we are checking in for intercept variance and slope variance, right? So slope variance tells us that how much impact of study hours varies across these 30 schools. Large variance proves that studying is highly effective in some schools but barely matters in others. You interpret the slope variance, keep this in mind, only if you have selected random slopes model. So we have to interpret this only if we have selected random slopes model. And then we interpret the residual variance. So actual minus predicted value is known as residual, right? It represents the unexplained student level differences. Unexplained student level differences left over within the schools. So student level differences in each of the schools as per the regression equation, which is we are predicting the value of y based on intercept plus slope multiplied by independent variable plus residual error, right? This is the regression equation. So for each school, this predicted value depends upon the intercept, it depends upon the slope, it depends upon the independent variable, and it depends on the residual error. So it represents the unexplained student level differences left over within the schools. Now, after this, we have interpreted the results of random effects. Next, we extract and visualize school specific lines. So the mixed model helps us to calculate specific predictions for each of the 30 schools, which is known as empirical Bayes estimates. So specific predictions can be estimated for each of the 30 schools through mixed level modeling, right? So then we finally generate a final plot which shows 30 distinct regression lines overlaid on a scatter plot of 600 students, because each school we had 20 students each, right? So total is 600 students. So finally we generate a plot which shows 30 different regression lines like this, because each line belongs to a different school. Says this is school 1, school 2, as I told you in the beginning, right? 30 schools. And we report the findings. So in reporting the findings, we include the intra-class correlation coefficient. We include the model comparison, which is done through information criterion like AIC, BIC, likelihood ratio test. So we include the results on the base of which we selected which model to go with. And then we also tell the estimates, standard errors, estimates, standard errors, t values, and p values for final model parameters. So for the final model which we have selected, we tell all this in the findings, we report it in the findings. So I hope this video was informative and useful for you, and I'll definitely make a video wherein I will practically demonstrate how to conduct this mixed effect modeling or multi-level modeling in Jamovi software. Okay, so we can also do it in latent cold software. So just wait for the time, and I'll surely prepare that video in a very short period of time.